In this first example, we're going to differentiate this function here using the rules of differentiation that you looked at in the module for sums, products, and quotients. Now in this example, just by looking at it, you might notice you can expand the brackets, which we'll do quickly. So the first term there, x squared times x4 will produce x to the 6, and x squared times 3 will produce 3x squared. Minus 4 times x squared will produce, minus 4 times x to the 4 will produce 4 times x to the 4, and then we multiply by minus 4 by 3, will give you minus 12. At this point, you can just differentiate as usual, term by term, bring the power down to get 6x to the 5, the second term, bring the power down to get 6x squared. The third term, bring the power down, 4 by 4 is 16, and the last term differentiates to 0. So that's, you might simplify, just ignore the 0. So that's the answer to that one, but it might be worth trying to do this in a slightly different way. Some of you might have noticed that since that's a product of two factors, you'll be able to use the product rule as well, and that's indeed the case. So let me just recall the product rule here, which is if y is u times v, then dy dx will be given by u dv dx plus v du dy dx. So you just alternate differentiating each of the terms u and v and add them together. So let's use that here. So just write another approach. Alright, so let's think of this one as u, that one as v. So the derivative according to the product rule, if we just grab that in there, that will be u du, oops, that's a v. Now, the u is x squared minus 4. The dv dx, well, what's the v? The v is x to the 4 plus 3, so dv dx will be 4x cubed. The v there is x4 plus 3. And what's the du dx? Well, the u is x squared minus 4, so du dx is 2x. So if you put that all together, that will be x squared minus 4 multiplied by 4x cubed plus the rest of this. Now, that looks like another answer, but if we simplify this, hopefully we'll get the answer that we did using the previous method. So this, it's just expanding this quickly, that's 4x to the 5, 16 cubed, plus 2x to the 5 plus 6x. I notice you can combine the x5 terms there to give 6x to the 5 minus 6x cubed plus 6x. Oh, and I noticed I made a mistake in the first example. So I think you may have spotted that I made a mistake up here in differentiating this term. That should have been just 6x because you dropped the power 2 down. So that should not be there. So with that adjustment, the two answers more or less coincide.